All right, good afternoon, everyone. Welcome to another one of our lessons for Technology Grade 7. My name is Mr. Alex Songo. Ladies and gentlemen, I'm so pleased to have all of you here today. I see that we have about 16 people so far that are joining us. It's an absolute pleasure to have you guys here. Thank you so much for being here. I just want to have a look at the chat because I see there's a lot of flashing. Please kindly let me know if, again, today, there are blank blocks on the screen so that I can be able to assist in that regard. Welcome, Tiamo. Thank you for joining us. Nishenia, welcome. How are you? Thank you so much for being here. Guys, we truly, truly appreciate you being here all the time. It's been a wonderful couple of weeks with all of you. Hello, Kia, how are you? Where is Tiana? Is Tiana here today? Yes, Tiana is here today again. So we are so glad to have you guys here. All right, ladies and gentlemen, let us get right to it and see what it is that we are doing today. Now, as a norm, we have corrections from the previous lesson. By corrections, I mean we are going to look at some of the responses that you guys might have written or done with regards to an activity that we do each and every day. Now, the first requirement was that you apply triangulation or reinforcement into the following shapes. Ladies and gentlemen, I will then revise what we mean by triangulation. Triangulation, ladies and gentlemen, is putting members in a shape so that you create a triangular shape into those members. By so doing, you are reinforcing the structure or shape to make it stronger. So ladies and gentlemen, the first one is a triangle. I did say that it was actually very interesting because we were asking you to do triangulation in a triangle. I just want to see. Hello, Megan. Welcome, Megan. We have not seen you here in a while. It's so great to have you here. Tiana, you're always changing names. Sometimes it's confusing, but now I know. Sorry about that. Palisa, welcome. Thank you so much. I'm glad to see that there are no blocks. Thank you so much to Thiari for letting us know of that regard. Lifa, welcome. Thank you so much. I see a lot of people are joining us as we go. So ladies and gentlemen, in the triangle, in red, I have put in the members. Remember what we said members are? Members can be seen as struts because they are rigid or they are hard. So if you introduce this member that is red, or that line, if I may, so that you understand me, you find that you've got two triangles. You introduce another one, ladies and gentlemen, you end up having 4. You introduce another one, you end up having 8. So all of these, regardless of how you have done it, as long as you put in a cross piece, which therefore makes the shape have a triangulation or triangular shapes. I hope you understand as we have done here. Let us go to the second one, which is the rectangular shape. Ladies and gentlemen, the first thing obviously here is to draw a cross piece that will move from here all the way to the further right. So immediately you then have got 2 triangular shapes. When you draw another one from the top here, by top, I'm referring to the left-hand corner on the side at the top there. When you go down to the right-hand corner at the bottom, you end up having 4. And then you, of course, introduce another one and you introduce another one. But as I said, the whole point is so that you've got triangular shapes in your object or in whatever diagram you want to triangulate. Ladies and gentlemen, I hope we understand. I am trying to access the chat box so that I see if people understand. Oh yes, okay, I understand now. Figile, welcome, thank you so much. Good afternoon to you. We were still on the corrections of yesterday's activity so that we can speak about what we were doing and we can, of course, revise and see if there was some form of understanding. Now, let us go to number 2. Number 2, ladies and gentlemen, was asking you to use your knowledge of forces so that you complete the table below. So you were given these parts that are called structural elements in a cell phone tower. You were given struts, you were given tie beams, you were given guys. Now, ladies and gentlemen, what you have to do is to decide whether each of these ones, what type of force do they actually enforce, if I may, or what type of force do they do? Let me revise the first example. We said compression is when you are pushing something. So you're pushing something in a direction that is coming in the same direction. We then said tension force is when you are pulling in different directions. What does it mean? It means someone is pulling on the right or to the left, or you're pulling up and down, but therefore there is tension. So when we talk about struts, ladies and gentlemen, the force there that is actually applied by struts is compression force. What does it mean? It means that the struts are important in stabilizing the cell phone tower in a way that it brings them together or it pulls them in the same direction. We then go to tie beams. Tie beams, ladies and gentlemen, what do tie beams do? It's a tension force that they apply. What does that mean? It means that you are moving in opposite directions. Guys, which I said are cables that are found on the sides of cell phone towers, where cell phone towers that are mostly not wide in their base. So if the cell phone tower base is linear, in a lot of instances, they introduce a reinforcement technique, which is a guy, so that that cell phone tower, ladies and gentlemen, can be able to be embedded or anchored onto the soil. I hope you all understand. Kiandra, you're not too late. We were still looking at the corrections from the previous activity. Thank you so much for joining us once more, Kiandra. Tyrone, welcome. Thank you for being here. Let us move on. So I want us to look at some of these examples of structural elements because I feel these are important. Why do I feel so, ladies and gentlemen? Because some of us maybe were not here yesterday or the day before, or we just need a bit of more reinforcement. See what I did there? So maybe we need a bit of more reinforcement in relation to reinforcing the parts of a cell phone tower. I'm simply just using a lot of puns there to play around with words. I hope we understand. All right, so this is an example of a cell phone tower. A lot of us have seen this, ladies and gentlemen, but we are obviously technologists. What does it mean? It means that our focus is largely on the technicalities of the cell phone tower, the structural elements of the cell phone tower. The first thing to understand is that we've got what we call the force of gravity. What is that for those that do not understand? The force of gravity, ladies and gentlemen, affects the earth in a way that means if everything goes down, there's a force that pulls it all the way to the ground. So right now, if you throw something up in the air, it will be brought down, of course, unless you are in space. And when we talk about space, which is planet Earth and beyond in natural sciences in the fourth term, we touch on that. But this is technology. We are just explaining so that people understand, and we're using a bit of integration there. So ladies and gentlemen, in our cell phone tower, if you can have a look at the structural elements there. The first thing are columns. I've put an arrow in red, which is showing us the columns. So the columns are actually found in between or in the middle of the cell phone tower itself. These are the columns. So what do the columns do? They are vertical structures. What does it mean? They are up or down, down to up. That's what vertical means. In mathematics, we learn about this all the time. All right, so what do? They hold the weight of the structure. What is the structure that they are holding? The cell phone tower itself. And of course, that is applied, the force that is applied by all the structures that are found at the top. Ladies and gentlemen, let's move on to guys. Remember what I said? I said guys are the cables that are found on the side of the cell phone tower. They are important to anchor the tower to the ground. What does anchor mean? They attach or they make the tower stable. In natural sciences, we're going to be talking about roots because roots anchor the plant to the ground. Ladies and gentlemen, I hope you understand. Tyrone, we are simply still speaking about yesterday's lesson. Mushuri, welcome. Thank you so much for being here. We are actually going to go on to the investigation of telephone systems today, and that is what we are going to be talking about. Thank you, Tyrone, for your question. This is going to assist us again, Tyrone, when we speak about the PET out of 70 marks that we need to do. But we cannot do the PET without establishing a form of foundation so that we can be all on the same page. So, ladies and gentlemen, again, what did we speak about yesterday? Triangulation. Triangulation is putting members in a frame structure to create triangular shapes. That is the first thing that we spoke about yesterday. We then spoke about pylons, and we said pylons are an example of a type of tall frame structures that hold or carry heavy loads. Then we spoke about mine head gears. I said to you, the mine gives it away that this has to do with the mine, and the headgear means this is at the top of the mine because the head is the top part of our bodies. So mine headgears are found at the top of mines. They are used to transport mine equipment or anything that might be needed by miners underground. We then spoke about reinforcing techniques. Ladies and gentlemen, all of these are examples of techniques that reinforce or further stabilizes a cell phone tower, namely columns, which I said are like beams, guys, which are like cables. Ladies and gentlemen, I hope you understand. Yesterday, there was a request to play a video, which unfortunately we did not play well because of some technical challenges yesterday. I want us to play that video now so that we can be able to be on the same page. So please excuse me as I access that video so that we can play it and then we can have an understanding of a revision for yesterday's activity. Please just give me a couple of minutes. We'll bring it up just now. Ladies and gentlemen, remember, if you've got a question, please do not hesitate to put your question in our chat box so that we can respond to that question. All right. Okay. Noted, Thiari. Thank you so much. All right. I am trying to access the video. Apologies for that. It is going to be playing very soon. I'll have to share a different screen. Awesome. It's coming.
Concrete or steel cell phone towers can be strengthened in a fast and safe manner. The biometric system developed by Professor Moasani. With increased use of mobile communication worldwide, cell phone towers are expected to support more antennas and heavier loads that exceed their original design capacity.
Okay, I seem not.
Demonstrates how concrete or steel cell phone towers can be strengthened in a fast and safe manner with the patented biometric system developed by Professor Moasani. With increased use of mobile communication worldwide, cell phone towers are expected to support more antennas and heavier loads that exceed their original design capacity. This requires strengthening of the towers. In many cases, these towers are located in congested urban areas where the use of guy wires is not an acceptable support option. A compact strengthening system that can be performed in tight spaces is desirable. The technique we have developed allows us to model and
Please let me know if you can see the video, guys.
Loads, including wind, seismic, etc.